Good morning, students. So today we are going to discuss about three things, that is EMF, internal resistance, and terminal voltage. So students, this is a very important topic for current electricity chapter, and most of the students, I will not say all of the students, but most of the students are very confused with EMF and terminal voltage. They don't know the difference between EMF and terminal voltage. So for understanding these all terminologies, we should be well aware about cell. So what is cell and how to define cell? So a cell is a source of energy. Cell is a source of energy which converts which energy to which energy. So cell is a source of energy which converts chemical energy into electrical energy. So students, learning this definition is very easy. Even you have done it in your previous classes as well. That cell is a kind of arrangement which converts chemical energy into electrical energy. But we are not aware about that how this process will be occurred. So this is very important to understand that how this process will be occurred. So let us consider a cell. I have drawn a cell, and inside a cell, what is the picture inside a cell? So the answer is the cell is filled with a solution, and that solution is known as electrolyte. Inside the cell there is a solution, and that solution is known as electrolyte. So right now the electrolyte which I am considering in my example is H2SO4 sulfuric acid. Okay, so this sulfuric acid is working as a electrolyte. Fine. Electrolyte solution we have filled, and then we introduce the electrodes. Okay, what is electrode? So the answer is the electrode is a kind of rod that can be of any metal. So for considering the example of the cell, the electrode which I am going to introduce inside the cell, let me draw it in well manner. So the electrode which I am going to introduce inside the cell is zinc electrode. So zinc electrode I have considered inside the cell. Zinc. Okay, zinc electrode I have introduced inside the cell. So whenever once you introduce the electrode inside the cell, then one chemical reaction will start occurring, that this H2SO4 will start its ionization. So how this ionization will occur? This H2SO4 will start breaking it down into the ions. Okay, this can be a reversible reaction, or this can be a permanent reaction depending on the nature of the cell. So this is a permanent reaction for all cells. So H2SO4 will be converted into hydrogen ions plus sulfur ions. So this is how it will break down. 2H plus ions plus SO4 minus ions are separated out. So students, what will be the advantage of this? So students, as you can see, sulfur ion is there, sulfate ion is there. This sulfate ion will have a tendency that this will try to react with zinc electrode, because we have inserted the zinc electrode inside the cell. But the problem with zinc electrode to react with this sulfate ion is that zinc electrode carry no charge, and this sulfate ion carry the negative charge. So we are not able to actually react this zinc electrode with the sulfate ion. So how this zinc electrode will able to react? So students, the solution is very simple, that this zinc electron, what zinc electrode required to react with sulfate ion? The answer is the zinc electrode can react with sulfate ion once this will be positively charged, because there are two negative charge. If this will be too positively charged, then this can react with sulfate ion. So for getting the positive charge inside the electrolyte solution, this will send two of its electrons, pair of electrons in the upward direction. Once the pair of electrons will be transferred in the upward direction, the advantage of sending the two electrons in upward direction, that earlier the zinc, which was having no charge inside the cell, inside the electrolyte solution, this zinc has two positive charge. Why this zinc have two positive charge? Because two electrons it have already loosed. So when this will lose two electrons, then this zinc will able to react with this sulfate ion. From where we are getting this sulfate ion? The answer is, this is the electrolyte solution which was already broken down. So when this will react with this sulfate ion, ZnSO4 will be formed. So our motive is not to form ZnSO4. Actually this is a residue. Okay. We are not doing this reaction to form ZnSO4. Our motive is little bit something else. So what is our motive? Our motive is to keep on going this reaction. So just to continue this reaction, this zinc will keep on sending its electrons in the upward direction. So one electron, two electron, pair of electrons will be transferred in the upward direction. And once these electrons will be transferred in the upward direction, this reaction will keep on going. ZnSO4 will be keep on drawn. Okay, here. So this residue will be continue to form. And what is the advantage of this? The advantage of this is, you can see clearly, this electrode is negatively charged now. This is offering a low potential. So for utilizing this low potential, we can now introduce a resistance, okay, a load resistance in the cell, and we have inserted, suppose we have inserted one more electrode inside the cell, because you already know there are two electrodes inside the cell. So this electrode, once you will introduce and you will join it along with a load resistance, then what is the advantage of this? And of which metal we are taking this electrode? So I have considered this electrode is made up of copper. So this is made up of copper, and now this charge will, now these electrons will be transferred from the, as this you can see clearly, this is a low potential and comparatively this is getting the high potential. So electrons, the pair of electrons will be keep on transferring from here to here. And when you know there is flow of charge, there is flow of electrons, pair of electrons are transferred from here to here. Whenever there is a flow of charge, there is a flow of current. So electrons are transferred from here to here. So current will be transferred from this end to this end. So this is the direction of current. And this is how we have done a wonderful job, that we have introduced the current. So this is how the chemical energy inside a cell is converted into electric energy. Now, one thing is clear, that H2SO4 will keep on breaking down into H plus ion and SO4 minus ion. SO4 minus ions are busy to react with zinc, and zinc is busy to send its electrons in the upper direction, so that this current will keep on flowing. And what about this 2H plus plus? This we haven't utilized. So students, once these electrons will be transferred from this end to this end, these electrons are here, pair of electrons, pair of electrons, pair of electrons. What will be the advantage of this? So these electrons are available inside the electrolyte, and inside the electrolyte H plus ions were present. So this 2H plus plus ions will able to react with two pair of electrons, and hydrogen gas will be formed, and this hydrogen gas will be released. So inside a cell, two things will be done, two reactions will be done. One, that hydrogen gas will release, and one another thing, ZnSO4, zinc sulfate residue will keep on forming. So our job was neither to have hydrogen gas to be released out, or not the job to form ZnSO4. Our job was just to transfer the charge, and that is done. So once there is a transfer of charge, there is the formation of electric current, and this current is due to the chemical energy, this reaction, okay, this ionization reaction. So until this ionization reaction will keep on doing, means this H2SO4 is capable enough to break down, then till that duration the same reaction will keep on going. So this is how the circuit will work. Okay, so this is how the chemical energy is converted into electric energy. I hope this topic is clear to you. Now students, one more thing is there which you haven't thought yet. So if the current is keep on flowing, the charges are there, the charges are transferred from here to here, okay, lower end to higher end, this end. So the charges have to be transferred from this end to this end, which we never thought about, because there is a closed loop. Okay, we always speak about that from here to here, from higher to lower potential, the charge is flowing. So once we are assuming about terminal voltage or terminal potential, we are only considering this, the potential difference between the two terminals. We are not considering that what will be actually done inside the cell. This picture will be very clear to you once I will explain you EMF. So I have to erase this. I hope you understood this cell topic. Okay. So let me erase this. EMF, electromotive force, that is the full form of for EMF. EMF is, let me erase this as well, the amount of work done, the amount of work done to bring a unit positive charge throughout the cell. Okay, whenever we are considering EMF throughout the cell, then we have to actually do all the things. Means the charge will be transferred from the electrons will be transferred from lower end to the higher end outside the cell, and the same electrons have to be transferred from higher end to the lower end inside the cell. And when this reaction will be occurred, then electrolyte will offer a resistance. The electrolyte will not allow the electrons to be transferred from this end to this end easily. Okay, so the internal resistance which is offered by the electrolyte is known as internal resistance of the cell. Okay, so once we are considering about EMF, we have to consider that unit positive charge have to travel throughout the cell, means this internal resistance will be counted, and when we are calculating terminal voltage, we just speak about the charge to be flow from one potential to the another potential. We don't consider this internal resistance in the cell. Okay, I hope you understood this. The picture is clear to you. So this is EMF. You have to consider the charge to be flow through a closed loop outside the cell as well as the inside the cell. Okay, and internal resistance, and this EMF is measured in volt. The unit is similar to that of the voltage. And internal resistance, what is internal resistance of the cell? The resistance which is offered by electrolyte to the flow of charge inside the cell. Okay, this is known as internal resistance of cell. Okay, this is denoted by small r. What is the role of this? You will be able to understand. Suppose there is the terminal voltage. Terminal voltage is the potential difference between the two terminals of the battery. Okay, so suppose this terminal voltage is V, and we have to calculate EMF. So EMF is the total work done done to bring the charge throughout the cell. Okay, so we cannot say that V is the total work done. V is the work done to bring unit positive charge from one end to another end. This only external resistance is counted. And once you will introduce the internal resistance and you will count the energy loss inside the cell. So suppose I current is flowing, okay, and internal resistance of the cell is R. So E is equal to V plus IR. EMF is the sum of potential difference, means terminal voltage that is available in the two terminals, across the two terminals of the cell, plus you have to count the energy loss due to the internal resistance of the cell. So EMF of a cell is always greater than the terminal voltage of the cell. Okay, so this is how you can picturize about this all topics. I really hope you understood this. So thank you. God bless you.